Hello my friends, welcome again to my video channel. Today we will continue our work on the Drake TR7. First I will remove this modification here, which is intended to extend the receive range down to 0 for the lower 500 kHz bands, 0 to 500, 500 to 1 MHz and 1 MHz to 1.5. We have seen that this range is occupied. The problem is the LED here, set band, was always lit. The reason is there are some diodes missing. There should be some diodes more to indicate which set band is the right one. So the internal ROM, which controls the frequency, is satisfied to see, okay, this is the right band setting. These diodes are not installed, so the function of the receive is given, but we have no correct indication of the band setting. So I will remove these ones. The owner said he doesn't need it, so I take it away, because additional diodes can always be a source of trouble, and he doesn't need the range below 1.5 MHz. These diodes are out, and now we do the first check of the transmit path of the PA. The PA brick is connected. This brick is connected also to 13.8 volt DC to my power supply. Now we can do the check. I will start in mode CW. I can key it. And what I hear nothing, no side tone. We should have a side tone. Nothing heard. I only hear a very low frequency tone. Maybe the side tone is not adjusted correctly. We will do this later. I check the output power. We are on 80 meters. I can go up to 100 watt. A little bit more. Current is 20 amps. We have here the ALC lit. You can see it. No, you can't see it. Sorry. Here it is, 100 watt. Let's go to other bands. 7 MHz. Also 100 watt and more. ALC is okay. 14 MHz. Also have 100 watt. A little bit more, 120. Current is a little bit more than 20 amps. It's 22 amps, 23 amps. 21 megahertz. And here we have a strange behavior. Power goes up to 50 watt. Then it stops. The current is now 20 amps, 22 amps. No more output. Can't get out more than 50 up to 60 watts. And when I increase the drive power, the output power drops. And the current is unstable. The power supply is unstable, not a good sign. 28 megahertz. Again we have 80, nearly 90 watt, that's okay. We cannot expect full 100 watts. The ALC reacts now, so we cannot expect full 100 watt on 10 meter. But the behavior on 21 megahertz is a little bit strange to me. I don't know what's going on there. Okay, it gets a little bit warm. This PA brick is a little bit thermally over-dimensioned. Very good. But again, on 21 megahertz, we have here a rather strange behavior. The current drops suddenly. The output power also. I don't know what happens. We have a true 50 ohm load. Could be a sign of self-oscillation in the PA brick. I will have a look to the spectrum analyzer. Maybe we have a problem in the low pass or high pass filter. This could be checked with receive path, but I will check the output power first with the spectrum analyzer. My dummy load has an output minus 60 dB attenuation, so 100 watt output or 100 microwatt on the analyzer. That's 0.1 milliwatt or minus 10 dB, minus 10 dBm. Top line is 0 dBm, so minus 10 dBm is 100 watt. We are checking it on 20 meter with a 14 megahertz signal. And to see here we have 10 megahertz per division, and on the left side we have the zero response. This is 14 megahertz, and the first even harmonic is 28, and then the third harmonic cannot be seen. That's okay. And now when we go to 21 megahertz, I increase the output power. This is 21 megahertz, and suddenly when I increase it further, what do I wrong? You see here some signals coming out. I will increase the resolution and do the measurement again with the digital storage. Now we have 5 megahertz per division, center is 25 megahertz, here we have 0. So we have here 21 megahertz signal, and when I increase the power further, we see suddenly there are coming signals out which do not belong to the wanted signal. Let me take the maximum hold, not to overstress the PA. That's it. What do we see here? We have here the 21 megahertz, and we have here with plus minus 10 megahertz or so, we have here a signal on both sides which I cannot explain. They shouldn't be there. This is a harmonic. 25, 30, 35, 40, this is 42 megahertz, 21, 42. That is the even harmonic, but these two signals here I don't understand, and I'm quite sure they are much bigger than they are here, because we have a low pass function behind the PA. There's a low pass filter, and this could be attenuated by the high pass function in front of the PA. Maybe, I'm not sure, but this one here is very suspicious, and this one also. What do these signals here? I didn't see these two signals on other bands, only in the 21 megahertz. There is something wrong. To take out the PA brick, it is sufficient to remove these 4 screws. Then we can take it out in this direction. Hopefully there are no modifications and the wiring has the original length, and it is possible. If not, I have to unsolder something. We will see. The PA brick is out. We only had to unsolder the input for the pre-driver board. It's a power supply 12 volt TX, which is connected here and here, which gives a 12 volts to the brick. Here the pre-driver is supplied with the 12 volt, and the 12 volt TX is used for the biasing of the transistors, and we need of course the output. Well, I've seen something. The owner told me I have to check it. The final transistors, the 2 finals, should have been replaced by matched pair. Okay, we will see. But I saw another thing which is optically not so good. I will show you. The resistors here on both sides of the 2 power transistors are different types. These seem to be the original ones. These seem to be replacement, at least this one and the resistor underneath. These 2 are new ones. This could be the old one. Maybe they were damaged during a fault when the power resistors were replaced. Maybe they were faulty, and this caused the death of the resistors. And here we have some solder activities, sorry, on this coil. Don't know what it is. Maybe it is damaged or was damaged and was resoldered. I will rewind it, not a big topic. These resistors here, I will show you in the schematic. Here we have the two power transistors, and these three resistors are what we are talking about. We have here one resistor to ground, 10 ohm, another one that's 2 ohm, and a series capacitor of 100 nanofarad. It's for damping oscillations. Same principle as we have here. This is obviously for very low frequencies because we have here an inductivity in series. This is the one which has a solder on it. And when this transistor goes faulty, maybe the base and the collector is connected, so this resistor is instantaneously burned or killed. But these two resistors have a capacitor in series. They shouldn't be killed by an overvoltage here. Okay, I will take out this whole board and check it and see what's going on there. Another remark, of course, these resistors, when they're replaced, should be resistors without inductivity. Wire wound resistors are forbidden, and even other resistors which have a small inductivity, which are coiled. You know the principle of coiled resistors. They are coiled for alignment. Couldn't also be used here. It should be resistors without any inductivity. Maybe that's the problem here. Now we are at the end of part 6. We have seen that there is something to do. This brick requires a special attendance. We will see in the next video what's going on there. Stay healthy, stay tuned. See you on this channel.